Example 15. A square pyramid of 40 mm side and axis 70 mm long has its base on the HP with two edges of the base perpendicular to VP. It is cut by a section plane perpendicular to VP, inclined at 45 degree to the HP, and bisecting the axis. Draw its projections and true shape of the section. So here again we are going to have now we are having a square pyramid of side 40 and axis 70 mm long. It is directly resting with its base on HP with two edges perpendicular to VP. So this is a simple case of a square pyramid directly standing on the HP. The top view will be a square and the front view will be a triangle. And it is mentioned here that it is cut by a section plane inclined at 45 degree to HP and perpendicular to VP. So we have to place the section plane in such a way that the plane should be inclined to HP. For that, first we will assume that the section plane would be parallel to HP, and then we will make its inclination at 45 degree. And also mentioned that it is bisecting the axis. That means we have to pass the section plane through the center of this solid. And now draw its projection and true shape of the section. Now, this is going to be interesting here. True shape. You haven't heard till now anything about true shape, but do not worry. First, we will draw the projections of this square pyramid. That is the top view square, the front view triangle. Then we will place the section plane at 45 degree to the HP, and we will do the sectioning part to the top view. We will draw the sectional top view. Then I will get the true shape, and I'm going to explain you about the true shape in a moment. Let's first see how to imagine this. Well, on your screen, this is our square pyramid directly resting on HP. As you can see, the front view is a triangle and top view will be a square, easily observed, and two edges are perpendicular to VP. So we'll see one more time. Here, the two edges are perpendicular as seen in the top view. And the section plane is given with respect to HP. Some angle is given. This is the parallel section plane. Now on your screen, the section plane is parallel to HP and perpendicular to VP because it is horizontally cutting the solid, as you can see from the front. And now I have to make some inclination angle. So this is the parallel plane. So I will tilt the section plane now. As you can see here, I am tilting it. So let us say the angle is 45 degree. So let us say this is the 45 degree angle as your screen right now. Now I am cutting it from the front, as you can see, and in the top view you can see some trapezoidal portion has been formed in the top view that will come in the section. So this is the 3D view, isometric view, the section plane inclined. So what I will do is, now observe it carefully. I will just remove the planes here. Now you can see easily when I cut the solid with an inclined cutting plane, the square pyramid will look something like this from the front, and from the top it will look something like this. The square base will be visible, but at the center you will find some trapezium like portion, trapezoid. This is going to be a final front view and top view. But here in this question we have to also draw true shape. We will see more about true shape now. So now you have to concentrate more carefully here, because we have till now we haven't drawn true shape of any figure. We haven't drawn true shape of any figure. So first I will tell you what is this true shape, and it is also called auxiliary view. So now you can see that we have already seen this is the section plane which is cutting the square pyramid with respect to HP. So in this white dots you can see this is our section plane as seen already, and I am viewing it in an isometric manner. Like you can see this is the front view and this is the top view, as you can see, but this is the other view. From this view we are viewing from this side. So this is the section plane here, and it is cutting the solid here, and as you can see that some trapezium like portion has been formed which will appear in the top view. but in the top view its length will get contracted. As we have seen already, the trapezium will not like this is the slant edge here. Let us say the length of this is 10 mm, but in the top view it will appear as 7 or 8 mm only because it will get contracted. So for if we draw this cut portion with true length, that is going to be called our true shape. So I'll show you, and this true shape will be drawn in an auxiliary plane. Auxiliary plane means the plane apart from horizontal and vertical plane. If we are taking another one more plane, this is going to be called an auxiliary plane. This is going to be called an auxiliary plane. Now you see that I have taken one plane here, as you can see here, this in green color, and this is being perpendicular to the cutting plane. So always auxiliary plane will be perpendicular to the cutting plane. What I mean by perpendicular, you can see that this angle is going to be 90 degrees. So angle between these two is 90 degree. You can observe here between these two planes, this plane and this plane. This is the auxiliary plane in green color, and you have this plane. This is going to be in green color. So I was talking about this figure here, where the portion has been removed from the solid. This will appear contracted in the top view. And now we will draw this same figure here in the auxiliary plane with the true length. So this is our main aim here. As you can see here, I have taken some lines here just to highlight this figure. Only this portion only which has been sectioned. So this portion here. Now we have to take this figure in this inclined in this auxiliary plane. Now when you view this from the front, it will get attached to this plane, this auxiliary plane. As you can observe here, just concentrate here. This portion has been taken here. So when you view it directly from the front, it will something look like this. That means if you view from the front, it will look. So just wait a minute. So this is our auxiliary plane, and now we have already seen this is the top view and this is the front view. So while drawing in the drawing sheet, what we have did is we have taken some lines from the section plane. This was our section plane here. This is our section plane. As you can see from the front, this is looking like a line. It will appear here, here, and we can draw the top view by projecting lines from the section plane. For drawing the true shape also, we will take from the section plane, as you can see here. So this is what we are going to draw in our drawing sheet. This is our top view. This is our front view. This is our auxiliary view, or otherwise called true shape, because it is drawn with true length, that is the actual length of the cut figure here. As you can see, if this plane is perpendicular, this length here and this length will be equal. That is why. So as you can see here, in 3D view, in isometric view or 3D view, this is our section plane cutting it here. This is the section portion. When you draw this in auxiliary plane, it will look like this, and when you view this auxiliary plane from the front, it will look something like this, and we have to finally draw this in the drawing sheet. So like, just don't get confused. You just need to draw this portion here, true shape. That's it. This is the top view, front view, and you need to draw this trapezium here. How, we will see in the drawing sheet now.
So as this is a square pyramid, first we will draw the projections of a square pyramid, and I will use first H pencil because as this is a question of section planes, the main answer will be after sectioning. So for drawing this square pyramid side 40 mm and axis 70 mm is given, and it's resting on the HP. So the top view will be a square and the front view will be a triangle, as we know, and the two edges are perpendicular to VP. So we'll get a square in this fashion. So this is our square. I'll draw diagonals also to get the center point. Now this is our reference line, say XY plane. This is our axis line, which is actually given in the question as 70 mm. So from the base 70 mm, I have to join this corner and this corner. So there you go. We have our top view and front view of a square pyramid resting on the horizontal plane. And now we will do the sectioning part. Section plane is given perpendicular to VP and inclined at 45 degree to the HP. The inclination is given with the horizontal plane. So we have to take the section plane here. Also it is mentioned that it is bisecting the axis, which means it will pass through the center of this axis. If this is 70, center is 35, and I am drawing one line here, just one line to take an angle of 45 degree. So this is our section plane. I'm just drawing with this pencil. So this section has been removed here. Now you know that. Now to get the sectional top view, we'll just number it for your reference. Like I will say this is first point, second, third and fourth. So this is the first line, second, third, fourth. And in the section plane also 1 dash, 2 dash, 3 dash, 4 dash. This is center O, this is O dash, and the section plane is cutting the 1 and 2 line at here. This is the section plane. I will project these points. I will get 1 point here and 1 point here. Similarly, this 1 point and this 1 point. All you have to do is just we have to join these points. Now, as this section has been removed, I will try to darken only this portion. The reason, as you know, this section has been removed, only this has been left, but the square base is visible. And now inside this portion we will get the hatching lines at 45 degree. So I will align the drafter scale, and I am using 2H pencil here. You can use dark pencil also. Now just name these points as A, B, C, D. This is the top view, sectional top view of the given square pyramid. But here in this question it is also mentioned that we have to draw the auxiliary view, or also known as the true shape of the section. If this portion has been removed, as I have explained in the earlier video, that the auxiliary view is a view from other than the front view, top view and side views. So this is our front view and top view. The auxiliary view will be in this direction. In this direction. So we will take an auxiliary plane parallel to the section plane. Anywhere here. So I will first project this two lines, and so we will draw a parallel line to the section plane. This is going to be our auxiliary plane. This is our xy plane. This is our xy plane. So I am naming this as x1 y1 plane, which is the auxiliary plane. So for getting the true shape or auxiliary shape, see that from xy line the B is at a distance of this much. So from the auxiliary plane you will get a point B, and again from the xy plane the distance of A. So this is your A point. Now we just need to join this A, B, C, D points.
So this is the final solution of a square pyramid directly resting with its base on HP. You can see the section plane being inclined to HP and passing through the axis, bisecting the axis. As you can see, if total length is 70, I have taken 35 distance. And here, this is our true shape, which we have already seen. We can draw this true shape by taking the projections perpendicular to the cutting plane, cutting line, and it should be drawn in a plane called auxiliary plane. This is our auxiliary plane. That is why I have mentioned here x1, y1, as we have already seen.